How do I make it fit? Fuck, what did I do? No, what do I do? Grace, what did I do?
Click that. Just.
Why is it so tiny? Why is it so tiny? Okay. But I want to do, like, full screen, but when I do full screen, it, like, cuts off.
Here.
I want this to, like, fit inside of it. No, when I did that, it cut it off here.
Okay.
That's what I'm saying.
Okay. I don't know how to make it full screen.
Like, I don't give a fuck. Okay. So my presentation is about earthquakes and how seismic waves are used to map Earth's interior. So we first learned about seismic waves and how there are two different types of seismic waves. There are P waves, which are primary, and they're the fastest waves, so they're able to travel through both solids and liquids. And we previously knew these as longitudinal waves, and you can see, like, the example here of a P wave, how they get compressed into each other, which is longitudinal. And we also learned about S waves, which are secondary waves, and these are slower, and they're not able to travel through, they're only able to travel through solids, but not liquids. And we previously knew these as transverse waves, so this is an example of an S wave, and how it kind of looks like an S when you look at it. So for the mapping the interior of the Earth, so seismic waves, like I just said, they, like, change speed as they travel through different materials. So that's how scientists are able to map the interior of the Earth using them. And yeah, so for example, we just learned that S waves cannot travel through liquids. So if we track the seismic waves and they suddenly stop, we know that that portion of the Earth's interior must be liquid because they aren't able to travel through it. And so the different kinds of waves travel differently through different materials. So waves travel faster through dense and rigid material. And this is because, like, when a material is more dense, their particles are tightly packed, just like this picture right here. And so, like, if this particle were to get disturbed, it would touch all of these around it, and it would make the energy be able to transfer through it way faster. Versus this one, where waves travel slower through softer or partially melted material, because if this particle were to be disturbed, it wouldn't really come into contact with the rest, so it doesn't, the energy doesn't travel as fast. And so waves also bend and refract when they move between the different layers because the different layers have different densities. And so the wave will, as it goes through the multiple layers, it will either slow down or speed up depending on that density. And this is, like, kind of similar to what we learned in our, like, wave unit in the second quarter, where, like, when a wave is traveling through a deeper pool, it, like, starts going faster as it gets deeper, which, like, kind of causes the wave to change directions, similar to, like, this picture where it's, like, air, which is less dense, and glass, which is denser. And so this can also give scientists evidence as to where boundaries are between layers, because they can see the exact point at which the wave refracts. Scientists use seismometers to track earthquakes and stuff. So when an earthquake occurs, scientists are able to track the waves that travel outward through the Earth. And they do this by having the seismometers on the ground so they can measure the vibrations as they go by. And from this, scientists are able to track when the waves arrive at the point of the seismometer and how strong they are. And then they can take this data and compare it to other earthquakes and previous data that they have, and they can figure out the exact location of the earthquake, the depth of the earthquake, and the makeup of Earth's interior. And through this, they have built models of their predictions of what the inside of the Earth looks like, and they're, like, accurate because we know all of this scientific data on how these waves travel. And so this is just like a breakdown of like how S waves and P waves travel differently throughout the Earth's interior and like how we can like know. So like for example, a P wave, it can travel through anything, so you can see the lines continuing to go through all parts of the Earth. And you can see like here it like refracts because it's probably going through something that is less dense, and so it's able to move. Whereas in the S wave pattern, the core we know is liquid, and so all of the waves stop as they get to the core because they're not able to travel through liquid. And so based on like these kinds of diagrams and like more intricate and complex data, scientists are able to map exactly what the inside of the Earth looks like and which parts are solid, molten, liquid, and solid metal. So yeah.